Continuing our lessons on acids and bases, and we're going to be learning about titrations and titration equations. So let's get started. So first things first, what is a titration? So a titration is a technique that we use to determine the concentration of an unknown acid or base. And we do this using a neutralization reaction. So the first part of this is going to be, we're going to need an indicator added to a specific volume of acid of where you don't know the unknown concentration. You can also add this indicator to a base and you don't know the concentration. So then you have a standardized base. They call it a base, but it's basically an acid or base of a known concentration. So we have our unknown concentration and then we have our known concentration. And then we're going to add our acid or base that we know the concentration to with a burette until the solution is neutralized and equals and reaches the equivalence point. The equivalence point is basically where your H plus and your OH ions equal the same. And this equivalence point will not always be where the pH is 7. Adding one more drop of base will turn the solution pink if you're using phenolphthalein, which turns pink in the presence of a base. This is called the end point. So y'all are going to work on this and y'all will see a video and y'all will be able to work through this and see a video of what this will actually look like. But this is a picture. So the burette that we were just talking about is this long skinny thing. And actually here's another one right here. And I don't know how well you can see it, but they have a knob down here at the bottom. It's kind of hard to see because his shirt is white. But this knob, you turn it and it controls how quickly your liquid comes out. And so basically you're going to put it in slowly until it turns this pink color. You actually want it to be as light of a pink as humanly possible. So let's talk about calculations that you're going to need for these titration equations. So let's go through our equation. Remember, in a titration, you have either your acid or your base, and you know their volume, but you don't know their molarity. You don't know their concentration. Molarity is a unit of measure for concentration. So you have your molarity of your acid times the molarity of times the volume of your acid, and then you have this number of H pluses. So a lot of times you'll see acids with just one H. For example, we have HCl. And in this case of HCl, we only have one H. But not all acids work like that. You have some acids like H2S or H2SO4. Okay? And in this case, we would have two H's. Okay? Then we have our molarity of our base times the volume of our base equals our number of OHs. This is very similar. We can have something like calcium hydroxide. Calcium hydroxide has two OH molecules or OH ions, whereas NaOH, sodium hydroxide, only has one. And so that's when the numbers here would change. When you have in your equation, you have a different number of H's or OH's. And then just as a reminder, if you have your pH at your equivalence point, meaning when your OH and your H plus are equal, is not always going to be 7. And for my pre-AP kids, we already learned this on Friday. So let's look at our first equation. So it took milliliters of 0.5 molar NaOH to neutralize 50 milliliters of hydrochloric acid. What is the molarity of hydrochloric acid? So the first thing we're going to do is we're going to put number. So the first number that we have is this 75, and it's 75 milliliters. Milliliters tells us that it's going to be volume, and since this is talking about NaOH, it's going to be the volume of our base. So we're just going to go in and we're going to put our 75 right in here. is 0.5 m. M is molarity. And so M is going to go into our M spot. And so it's going to be 0.5. And then last but not least, we look at our equation, and we have NaOH. We do not have more than one OH. We just have one, so I'm just going to write a 1 right here. And then it says it takes that to neutralize 50 milliliters of HCl. So I'm going to plug in, that is milliliters, is going to be my volume. So I'm going to plug in my 50 milliliters here. Okay, and then I look, and then it's asking what is the molarity of HCl, hydrochloric acid. So I do not know what my molarity is, so I'm going to put my X there. And then if I look at HCl, I only have one H. I don't have 2, I don't have 3, I only have 1. So I'm going to insert my 1 here. Okay, then I'm going to go in and I'm going to plug these numbers in. So over here I have 50 times 1 gives me 1. And then, so on this side I end up with 50x. And then on this side I'm going to use this calculator right here. I'm going to do 0.5. Clear. I'm going to do 0.5 times 75 times 1 equals 37.5. So I'm going to come here and I'm going to write 37.5. And so now I have my 50x over here and I have my 37.5 over here. I need to get this x all by itself. So I'm going to divide both sides by 50. And so now I'm going to do 37.5 divided by 50. And then that gives me 0.75. So my molarity, so my X equals 0.75. And then we were looking for our molarity. That's what we were looking for, M. And the unit for M, for molarity, is M. So our answer is going to be 0.75 M. And that's going to be our concentration for hydrochloric acid. Okay? So we're going to do one more practice problem. And here's our work for that problem. Or to our second example, and let's read the question. It took 20 milliliters of calcium hydroxide to neutralize 25 milliliters of 0.5 molar hydrochloric acid. What is the concentration of the base? So first things first, we are going to plug in our numbers. So the first number we have is 20 milliliters of calcium hydroxide. So we have our V is, well, let me make that smaller. We have our V here. So we're going to plug in our 20 milliliters here. And then it's asking for the concentration of our base. So when it asks for the concentration of our base, whenever we have a base, we're always looking for OH. So I'm going to put my X here. And then we have our number of OH. If you look at calcium hydroxide, they have a 2 down here. So this is going to be a 2 here. We're going to have 2 hydroxides. And then it says it takes 20 milliliters to neutralize 25 milliliters of a 0.5 molar solution. So our molarity is 0.5. And then our volume is 25 milliliters. And then HCl only has 1 hydrogen. So we're going to put a 1 here. So our next step is to come in and put this in our calculator. So we are going to do 0.5. Oops, that's not what I wanted to do. Clear. 0.5 times 25 times 1, which will give us the same thing, 12.5. So we have 12.5 over here. And then over here, we're going to clear this. We have 2 times 20, which gives us 40. So we are going to have over here, we are going to have 40x. So we want to get this x by itself, so we are going to divide both sides by 40. And so we're going to come over here to our calculator, and we are going to do clear 12.5 divided by 40 gives us 0.3125. I'm going to round this to the hundredths place, which is going to give me a molarity of 0.31 moles, or a molarity. So this is going to be my final answer. Okay, so y'all have a bunch of titration equations to practice this formula with. Y'all are awesome. See you soon.